So again, we want to figure out the displacement in 2D here. So what I'm going to do is separate the change in the y, or the change in the vertical, separate from the change in the horizontal. So we're going to go from A to B, although it doesn't matter if we go B to A. We can say going from A to B, our change is going to be this. Our end position is going to be at positive 22, and we started at a vertical position of negative 2. So our change, or displacement, is going to be positive 24. Okay, and then we're going to take a look at our x separately. The change in the x is going to be, we end at a position of 5. We started at a position of positive 9. So we went backwards. Okay, we went backwards negative 4. So now we can start talking about the ratio of change as well. So when we talk about the ratio of change of y to the change in x, the change in x here, we can say that the change is going to be positive 24 to negative 4. And if we want, we can simplify that ratio. We can also write it in this form: the change in y over the change in x. Okay? And we can write a ratio that way. So we end up with our ratio in a vertical form is positive 24 over negative 4. Okay, and again, that ratio can be simplified. Now this ratio is really what we're interested in. This ratio is called our slope ratio. This is going to give us the change, the horizontal and vertical change in our relationships. Let's do the next one here. This one here, we end up at negative 19. Okay, so our change in y, we should be fairly specific. We're looking at the change in y, so that we're going to say we're going from A to B. Our change in y is going to be, we end at negative 19, we started at 7, so we went down 26. Our change in x, we ended up at negative 39, and we started at positive 2, so we went down 41. Okay, so this is our changes, and we can write this as a ratio of change. And our ratio of change in y to change in x. And it's important to try to get this in the right order, because we normally talk about x's first and y's, but our ratio of change is going to be y's on top, x is on bottom. So when we talk about the ratio of change, it's going to be, it went down 26 and it went across left or backwards 41. Now, because it's a ratio, we can actually simplify this negative and negative. We can actually convert that into, just say, well, negative divided by negative is going to be, we can say it's going to be 26 over 41. We can just say the ratio is positive. And when we talk about the ratio of change, it actually doesn't matter in which direction we measure it. We could go left to right, or we can go right to left. When we start talking about slope actually doesn't have direction in terms of its ratio. Okay, but we have to worry about the positives and negatives, because we need to worry about whether it's going up or whether it's going down. So the last one here, if we talk about the ratio of change, we don't exactly know where we end up. But if we were to talk about the change in y, well, although I don't know where B is, I know that the change in y, or the displacement, is going to be end minus the start. I know it started at 8 and I ended at B. I don't know if I went left or right, but I know that's our change. Okay, and we talk about the change in x. I know I ended up at negative 7 and I started at A, although I don't know where A is. In fact, I don't know if I went left or right. There's my ratio of change. And if I want to write, there's my change in x. if I want to write my ratio of change in y compared to the change in x, although I don't know these variables, I can still write it in those expressions. Negative 7 minus a is my change in x. B minus 8 is my change in y. I can't simplify that because of the plus and minuses or the minuses involved in there, but I know that these expressions represent my changes in x and changes in y.